Hello, everyone.
I think
Good
what
morning and good evening. To authors and invited guests, welcome to Technical Session 6B. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, New York, USA. The 10th edition of the conference is being organized in a hybrid mode. Both the physical event and the virtual event is being held across 2 days, 23rd and 24th May 2025. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answer. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chairs. We have with us Mr. Ricky Sun, who is the founder and CEO of Altapa Inc. USA, a serial entrepreneur with over 20 years of experience. He's a world-class expert in high-performance computing, storage system, big data, having worked with leading Silicon Valley and Beijing companies such as Microsoft, Yahoo, IPD, and Splashdog. He has authored the best-selling technology books and holds more than 50 US and Chinese patents. Beyond technology, he is a connoisseur of ancient art and serves as a director of ancient art community at the Harvard Art Museum. We welcome you, sir. We also have with us Dr. Shyam Akashe, who is a professor in Electronics and Communication Engineering Department of Dean Interaction and Cooperation and Projects at ITM University, Gwalior. He has been serving as a TPC member in IEEE and Springer conferences. His areas of interest in research are low-power VLSI design, modeling, FinFET-based memory design, circuits for future VLSI technology, digital design, and FPGA implementation. We welcome you, sir.
Thank you. Thank you.
Thank you, sir. We'll be proceeding with the paper presentations from now. I'd like to invite our first paper presenter, Mutna H. Hamd, with the paper titled A Multi-Feature Face Recognition System Based on a Single Source Trait. Sir, if you're ready, then you may go ahead.
Yes, thank you for introduce me to this great, wonderful meeting. We start first with our paper with my colleague, Rabab Rasool. Just try to share this presentation. Is it okay? There is a title of my paper.
Sir, it's not yet visible, your presentation. You haven't started screen sharing yet.
I start sharing the net. Just to be sure you can see my presenter.
Yes, sir, it is visible.
Okay, let's start first. Yeah. Our research is a multi-feature face recognition system based on a single source trait. This paper is prepared by Prof. Muthanna Hamd and my colleague Rabab University from Musansara University, College of Engineering. Simply, in this research, we focus on the angle, which is a feature associated with the age. So we believe every trait, every human trait has an edge and its associated angle or phase. So we try leveraging this feature to build a unimodal system with 2 features and having all the benefits of multi-feature or multimodal system with a single source bio or single source biomedical system. First, every single source biometric system is essentially a multi-features model if the angle feature is utilized alongside its associated edge feature. This paper supports fusion levels-based edge angle multi-feature system. To evaluate the effectiveness of angle-based feature, an extensive experiments is conducted on 3 diverse facial datasets, AR, FEI, and CK+. 7 multi-level feature extractions are applied on 150 subjects. The recognition accuracy was assessed using various metrics, including false acceptance rate, false rejection rate, and 3 error distance measurements: the Euclidean distance, Manhattan distance, and cosine distance. This block diagram shows how the methodology of our research is going on. Any single source human trait, like a fingerprint, like an iris, like a face, like a fingerprint, like a palm print, can be applied in this research. But we focus on the face recognition, the most important one. Here we use a group of feature extractors. Actually, we use multi-levels. We call the first one primary high-pass filters, the Pruitt, Sobel, and Robert filters, and advanced one, which are the groups of texture description methods, the local binary pattern, local ternary pattern, and the gray level covariance matrix. And the third one is the advanced phase congruency. Because of the local binary patterns and the texture description methods doesn't have any angle in their output, just a texture. So we extracted the features in this stage using 2 phases. First, we apply the local binary pattern, then we mix it with the primary methods, the high-pass filter, and with the advanced method like a phase frequency. So initially, we have 2 uni-model systems, one based on the edge, call it edge feature-based biometric system, and the second one is the angle feature-based biometric system. These 2 systems can be fused together to enhance and improve the recognition accuracy rates and to be a robust model system and reliable one. So we can build multi-features, multi-model system from a single source, not multi-source, just from one source. And this figure shows how the edge and the angle is associated as a correlation one-to-one features in every.
Sir, we can see the first screen only.
Oh, really?
Yeah.
Just the first slide?
Now now we can see, now you're moving your screen, means you're shifting the slides. Earlier it was the first one.
Okay, that's you see the second one now?
Yeah, research objective and methodology.
Okay. We reach to the third one. I will not take an extra time. So this is the block diagram, which I talked about it. This is the table, show the comparison. We first apply the Pruitt, Sobel, Roberts, and we see the maximum rate exists with the angle. You see 93, 93, 95 with the Pruitt, Sobel, and Roberts filter. And with the second table, when we apply the phase frequency or phase congruency, sorry, we achieved the most 2 highest recognition rates exist on 95 with angle feature. Table 3 and 4, you see the angle satisfied 100% associated with the age, but the other distance measurement, the angle or the age advance the angle where it's satisfied 93 and 94 and 88 recognition rates. However, the third one, when I compound the two feature extractions, the texture descriptor and the phase congruency, again, the phase feature, the angle feature satisfied, achieved the maximum rate 94 with Manhattan, 90 with Manhattan as well, and 88 with Manhattan. This is with GLCM, the gray level covariance matrix, and phase congruency with the LBP and the linear tertiary pattern with the phase congruency. Here we see, this is the green for the color green regarding the angle, and the color red is for the age. When we accumulated the whole tables, the whole results, I will not talking more, we see still the age has the height, the what's called the height hand, or it's advanced the angle, but actually the angle is very competitive and satisfied the maximum in most cases, where the lowest cases is associated with the angle, where when we mix the texture description methods with the primary methods. This was the worst case. The angle doesn't satisfy the maximum rate. At the end, this is the databases that I applied for 150 peoples. It's the AR, contains 4,000 colored image and FEI and the CK plus. Conclusion. The experimental results show that angle-based features achieve high accuracy rates, performing competitively and often exceeding the performance of age-based features in most cases. This innovative approach has demonstrated how simple, low-cost, and easily implemented unimodal biometric system can achieve the advantages typically associated with more complex multimodal systems by leveraging a fusion technique without additional sensors or modalities. We didn't use any extra sensors, just face or image. Finally, the proposed system lays the groundwork that each unimodal biometric system could be functioning absolutely as a multi-features biometric one, if and only if activating the angle feature of a single source human trait. And thanks for watching and listening. Question, please.
Hello, hope I'm audible to Professor Muthana.
I'm listening.
Yeah, very good. So thank you very much. You're a nice presentation. My question is that what are the advantages and limitation of using single trait for recognition of multiple faces?
The advantage is we use a simple and low cost system having the same functionality and reliability of the multimodal system. So instead, if we have multi-sensors, multi-traits, every traits can be derived, because when we get the edge, there is associated angle with each edge. This is a one-to-one correlation between the edge and the angle. So it's very simple to make a relation between the edge and angle, use it as a multi-features biometric system.
Very good, very good. Now, my another question is that how is biometric data stored and protected in the system?
The data, what do we mean by the data?
Data, whatever the image, whatever data you scan or the images you scan, or that type of data.
Actually, I applied this work on 3 database.
Okay,
And
okay.
yeah,
No problem. Yeah, please.
sorry, may I misunderstand you?
No problem, no problem. It's okay, it's okay.
Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Vipin Bansal,
yeah.
titled Generative AI Application in Diabetic Retinopathy Detection Using Fundus Image. So if you're ready, then you may go ahead.
Yeah, sure.
Yeah.
Right.
Yeah. Hey, hi everyone. My name is Vipin Bansal, and I'm a corporate professional. I'm working from the last 20. A brief intro about me. I'm working from the last 20 years into IT industry, and from the last 10 years as working as a data scientist. And I'm a research scholar doing my PhD from Chandigarh University. And my research topic is to work on the diabetic retinopathy, like how AI can be useful to detect diabetic retinopathy using some kind of vision images, like some kind of images. In my case, it's a fundus images. So this paper that I'm presenting is a continuation of my previous model, which I've already published to one of the IEEE conference. So let me get started. So let me share my screen first. My screen is visible. Can somebody confirm?
Yes, sir, it is visible.
Yeah, okay. So I'm not sure. Okay, yeah. So, so yeah, so the title of this paper is Generative AI Application in Diabetic Retinopathy Using Fundus Images, and myself and my mentor Manisha Malhotra primarily contributed on this paper. So about the abstract, I would say that it's a, as I said, that it's how CNN can be used to diagnosis any diseases. Like we know that there are a lot of AI applications which is using MRI, CT scan. So that is the reason I thought, like, why we can't use the fundus images for detecting a diabetic retinopathy, right? So we have seen that diabetic retinopathy is, of course, it's a cause of due to diabetes. But in case if it can be detected at early stage, it can be controlled, and we can avoid some serious impact, which can be related to vision loss as well. So what is the current process? Current process is in diabetic retinopathy, a doctor or ophthalmologist manually evaluate the retinal images, can be fundus images, can be other type of images as well, right? Which can be error prone and depending upon the capability of each ophthalmologist. So in order to overcome this thing, AI-based solution named as VIT MAD, Vision Transformer based mask anomaly detector. As I said, that we already published a version 1 of this model, so it's an enhanced version of the previous solution that we that published under this conference. And again, it's trained on the various different kind of fundus images, as I said that. It's a kind of it's the whole solution is divided into two modules, where first we are generating the images, and on the second phase we are evaluating in the form of similarity score. And with a new improved approach, we are able to gain 2% gain collectively. Like on my previous paper, I was able to gain 96, means I was able to achieve 96.5, and collectively with a new gain, it's 98.11%, 1.11%. So it has been observed that it's a brief intro. It has been sorry, it has been observed that due to bad eating habit, diabetic is very prominent among youth people also. And due to diabetes, the diabetic retinal is one of the primary reason of due to diabetic retinopathy. As I said that it's a manual evaluation process which is time consuming and error prone. So how AI can help in AI can help in automatically detection of such diseases using utilizing the various retinal images. In this case, it is fundus images, and it can provide you high resolution, high precision rather, not resolution, high precision. And it's not it can reduce the dependency on ophthalmologists, but it's not replacing it, facilitating the existing ophthalmologist to earn or to present whatever the disease with a confidence, with a certain level of increased confidence, right? So as I said that it is based upon the transformer architecture, uh, reliable texture, which is a kind of generative architecture that we have used to generate an images. As I said that it is based upon the two module, image construction and similarity score. So currently we have seen that there are a lot of generative architecture. Generative AI is prominent one, but GAN and generative model is useful for generating those images. So I try to utilize the same concept for retinal images. And as you know that it is very difficult to get it is easy to get the healthy patient images, healthy person images, but difficult to get the actual patient images, right? Unhealthy images. So that is the reason I struggled a lot, and we build along with my mentor, instead of utilizing the both the category of the images, I build this system as an anomaly detection system, where I have used only the healthy images. And I'll explain you about the process, but it is utilizing only the healthy images for the generative part. For the similarity score, yes, we need both the type of images. Uh, so as I said, that is an extension of my previous paper. On the previous paper, although it was a improved version as compared to the previous techniques, but still it is missing a small lesion. So in diabetic retinopathy, what happens is the nerve got damaged, nerves or retina's nerve got damaged, and their fluid is leaked from those nerves, and that create a lesion or marks on the eye retina. So it can be very small, or it can be on the bigger side in case if it is highly impacted, if the person is highly impacted with a diabetic retinopathy. In case of small lesion, that previous paper struggle a bit. So that is the reason an improved version have been explored under this research. As I said, that is it is using transformer based reconstruction technique. And uh, and yeah, so need for improvement. So the core architecture is still the same. Anomaly VIT MAD, vision transformer mask auto anomaly detector. So it has been divided into two separate modules. One is anomaly generator, another one is advanced similarity evaluator. So anomaly generator is based upon the vision transform VIT MAE framework, which is a vision transform mask autoencoder. It's an existing previous research and how it works is basically is using a transformer based architecture to it initially it marks certain portions, certain grids of the images, and try to generate the mask grid. That is the ask of the VIT-ME solution. So I have utilized the same concept for anomaly generator, where I have tweaked some portion of that architect framework to make it more effective for small lesions. And I have optimized that code and trained with anomaly generator. I named as the anomaly generator, and that part is basically generating the images and just utilizing the healthy patient images. So that why I'm using the healthy images is as I said that during the diabetic retinopathy the nerve got damaged, it created lesions, which is kind of discontinuity on the pixels of an images. On the healthy images there is no lesion, there is no, so every pixels are smooth, adjacent pixels are smooth. But when we see unhealthy patients images, those pixels are not smooth. So with that assumption, if I feed the if I train my model with the healthy images only, gradually it learns the distribution of the healthy patients. So if I feed the unhealthy images, the model struggle to generate the similar pattern of that images. I can show you some of the example also. So that is the main concept for using anomaly generator. And later I am using the both uh, the generated images and the actual images for a similarity evaluator, which is based on the CMIS network, CMIS architecture, which is pretty known for the if you have seen that face detection system, right? It's a two parallel network which gets trained, and it try to create an embedding. That embedding is compared all together to create a kind of confidence level whether the two embeddings are similar or not. So in case of advanced similarity evaluator, earlier on my previous paper, I was using the actual actual image and the generated image as an input, whereas uh, this anomaly generator is based upon the autoencoder based architecture. So if we know that the encoder part is there, which is having a latent information. Latent information is a kind of again an embedding to represent a representation of that image. So instead of using the whole image, I'm using a latent embedding. Probably I can explain you with this architecture. If you can see that on the first part, on the top part, it's a anomaly generator, whereas on the second part, it's a kind of I would say that a similarity evaluator. So if you can see that it's based upon the autoencoder based architecture. It's a basically VIT MAE mask the base framework is based upon the same concept. So instead of using the generative image, if you can see, I'm passing the embedding of the upper model along with and concatenating with the original image to give a more presentation, and then feeding to the CMS network for a comparison analysis. And these are the some of the sample which have been generated. So this on the left hand side, this is the original image VIT mad. It's my previous research, whereas on the third side, the outcome of the this paper. So if you can see, I have highlighted on the bounding boxes the earlier on the previous paper, those fine details like the nerves are missing or not able, the previous model is not able to capture it. And on this on the updated version of that paper, on the current paper, with the current solution, I'm able to capture the more final details as it has been highlighted. So these are the outcome of our first module where I'm generating the images. So why I have used this technique? Basically, there are a lot of technique which is based upon the classification, but on the classification side, there is a problem of explainability. So that is the reason I have utilized this technique, where I can give a kind of confidence to the end user who is consuming that services. So it give you a kind of explanation while giving the reasoning behind it. And as I said that I was able to achieve better accuracy after this thing. Yeah, so uh, right, these are the some of the confusion matrices that I have captured. And uh, what limitation as such, it is again it can be improved. It could be possible since during the image generation it marks certain grids, and those masking is completely random. So it could be possible if even if the images of the patient who is having a diabetic retinopathy, but the mask grid are the portion which is good, or where there is no lesion mark is there. So in that case, model won't be able to predict whether there is a diabetic retinopathy or not. So in that case, a separate technique where a same image can be analyzed multiple times, so that at least on one iteration, at least some of the lesion can be captured at the time of generating the images should be considered. So yeah, and these are the some of the references. I mean, so all the references which is present captured on this paper. Yeah, thanks. That's all from my side.
So thank you very much for your presentation.
Yeah, thank you.
My question is that how does generative AI improve the diagnosis of diabetic retinopathy compared to the traditional deep learning methods?
See, as I said that deep learning methods can give you, traditional system is basically giving you a treating as a classification problem where it says the diabetic retinopathy true or false. But since you know that the nature of this model is it's a black box model, right? The confidence level won't be that much in that case. Why should we rely? How can we rely on the outcome, whether it's a true or not, right? So, but in case of generative AI, we are generating the images, we are segregating the
Yeah,
images, and that is the reason it kind of give you kind of confidence, right? So
yeah.
when we are saying that it's a diabetic retinopathy, a person is suffering from diabetic retinopathy or not. So it gives you a kind of confidence when
Hmm.
we are using generative images.
Okay. Okay. Thank you very much.
You're welcome. Thank you.
Thank you.
Thanks, everyone.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter, just a second, Zakaria Kanda, with the paper title RAG-based LLM for real-time cotton diseases prediction and suitable treatment suggestion. So if you're
Okay.
ready, then you may go ahead.
Okay, I'm here. I will see my screen.
Yes, sir, it is visible.
Okay, okay. Hello. Thank you very much for the opportunity to present our research with RAG system, a RAG-based LLM for written cotton disease prediction and stable treatment suggestion. In the study, our agenda is introduction. Firstly, we present the motivation of and problem and the material of and method we use in our study, and we will present the result and discussion, and we will finish in conclusion and the future work. Hello. Agriculture is the driving force behind Burkina Faso growth. The country crops are diversified, but cotton remains the principal crop despite in reduction in output owing to security conflict, power rainfall distribution, and cotton disease. For same year, plant pathology experts are focused that the study and the later in order to improve cotton yield by using detection. The problem in our study is the cotton diseases are difficult for plant pathology to identify across a vast area. And secondly, the cotton diseases are manual treatment, which is extremely costly in terms of time and human resource. Before the study, firstly we use before the model deep learning with drone image to detect the cotton disease. In the study, the goal is the goal of this research is to use a large model to classify cotton disease and provide a tool to recommend treatment for this disease. Firstly, we select study area. For the study, we use the meteorological data from Haut-Bassin region collected from the National Meteorological Agency of Burkina Faso, as well as plant pathology documents on cotton disease. We use 2,742 database of temperature, humidity, and rainfall variation from 2014 to 2023 year make the overall meteorological data. A variety of meteorological conditions will contribute of the growth of cotton plant disease, causing an important drop in production. These diseases have been classified into 3 categories. The first category is fungal disease. We have viral disease and bacterial disease. After the collect data, we use the pre-treated of our data. The distribution of variable, the rainfall variable distribution in this figure is extremely asymmetric to the right, with very little rain and occasionally with a median close to 0. The temperature distribution is homogeneous centric of 27 degrees and with little variation. The humidity distribution converges on value between 75% and 80% with modest asymmetric and few variation showing the relative stability. And secondly, the distribution of variable of disease show variable tendency based of climate condition. Fungal diseases are present in particularity each category of climate variation indicate their capacity of growth in variety of conditions. In contrast, viral diseases are almost not exist in the rainfall group. This is demonstrating their need and particularly environment. Bacterial diseases are flowing and similar trend to viral disease in their incidence. After the collect and treated our data, we use 2 models. The first model is BERT model. The BERT model we use with our data. The BERT model split data into segments to progress in context and then transform each segment into dense vector. And secondly, while user ask the different questions are also transformed into dense vector. The vector shares the similar to identify important segment and similarity. Each vector is a Facebook AIE similarity search index and enabling for quick research for segments that are almost similarity to the user questions. The model can be used to classification different types of diseases using the sigmoid function that calculate the probability for each class. We use this algorithm for our model, BERT model, for cotton disease classification of cotton disease and to suggest the treatment of cotton disease. The second model we use is Lamatu model with combined with RAG system to improve our model additional the BERT model, we propose combine the L-Llama 2 model with RAG system to improve the suggestion of treatment and general information on cotton disease. The system architecture is made up of information retrieval model and a text synthesis model that provide a accurate contextualized response. The system always user to submit the questions which are proposed to generate appropriate response for user and knowledge based on cotton disease. And so we use the algorithm for our model L-Llama with RAG system to propose the suggestion of treatment of cotton disease. After to implement our model, we evaluate the model. For the model BERT model, we use the accuracy, the precision, and the recall and the F1 score to evaluate our model. We use the different results for this model. And so we use of the loss function during the model training and testing step enabled, we observe the different results we observe a convergence of the curve, which tends to zero indicate the model performance on 15 epoch. And so we use the confusion matrix to observe the different variation with between our different class. We're using the confusion matrix to evaluate our model, enable to use to evaluate the classification to different class of our data. The confusion matrix show that there is confusion between the class, which might be caused by unbalanced our data. We observe that the development of cotton viral disease is unfold by rainfall. After the classification, we use the application to suggest the treatment of cotton disease. We develop a tool for the user. You can ask the different questions, and the model use the database to propose the different information for cotton disease and possible treatment. After the model of BERT model, we use the different result. We obtain the result of L-Llama with RAG for cotton disease to classify BERT. After using the BERT model to classify and suggest cotton disease, we use the L-Llama model with RAG to compare the result. We used again the response time metric was used to evaluate the result of RAG model. And so in comparing the response time of the L-Llama model with to BERT and GPT to generate a different response, to generate a response of cotton disease, we observe that it's slower than the other two models. With the assistance of plant disease, evaluate again our model, we were to obtain a value 3.8 for L-Llama and 3.3 for GPT on scale of answer of 5 answer to the relevance of the result we generate. This is an example for our model L-Llama 2 to generate the different answer for the user. In discussion, this article show the impact of climate data in the development of cotton disease. The results show the variation into classes caused to a power distribution and rainfall or during the data collect period. In comparison with to deep learning model used for drone image, the BERT model findings show its ability to its perform in identifying cotton disease. Compare model L 2 and the BERT model tool for suggest treatment of for cotton disease remains somewhat a limit. Its impact, unlike L with RAG that generate answer to user query. BERT file to generate answer that don't exist in its database, even if it run fast. However, to the hardware resource capacity, Llama with RAG longer to run for response generation than BERT. In conclusion, the study focused on using large language model to generate the suggestion for Burkina Faso cotton disease treatment. In the study, we used meteorological data collected in the Haut-Bassin region, Burkina Faso, and cotton disease document to propose the BERT model and Llama model with RAG system for classification and suggestion of disease treatment. Three principal type of cotton disease, bacterial disease, viral, and fungal were studied in order to classify the disease using BERT model. The result we obtained the different results with precision and accuracy F-score and an easy to interface use for the tool use to generate different questions. As compared to GPT, our approach showing Llama with RAG generate pertinent information on cotton disease. In the future work, we'll concentrate into improving the Llama model performance with RAG in terms of execution or speed of and result relevancy. It's also important to study other methods for treating cotton disease with textual and the image data. This is the different reference we use for our study. Thank you very much for your attention.
My simple question is that what type of model to be used? Is it a synthetic or organic?
Please, can you speak slow?
Yeah. Would your model is synthetic or organic?
We use the fine-tuning model.
Okay. Thank you. Thank you very much.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Karthik Sheshatri with the paper titled Assessment of the Knowledge-Infused Policy Gradient Approach for StarCraft. Sir, if you're ready, then you may go ahead.
Sure. I would like to screen share actually.
Sure, sir.
I think my screen is visible.
Yes, sir, it is visible.
Yeah, sure. So thank you everyone for giving me this opportunity to be here and talk about our paper assessment of the knowledge infused policy gradient approach for StarCraft. The authors of this paper are Adarsh, Karthik, and Vishwa. We all belong to the CSE department of National Institute of Technology, Andhra Pradesh. To start with, there's a growing need to take optimal decisions in dynamic and uncertain environments where it covers areas such as gaming to autonomous systems. So reinforcement learning, which is a subfield of machine learning, helps to train agents to improve their strategies by interacting with environments and learning from their feedback. So the key challenge in reinforcement learning is you have to balance exploration and exploitation. Exploration is like you have to discover new actions, whereas exploitation is using the known actions to maximize the rewards. So the traditional methods are a multi-armed bandit, which solves sequential decision problem, but it lacks something called context. So to include the context, there is something called contextual multi-band armed bandit, which enhances this multi-band bandit by integrating contextual information such as the game state or the environment, the surroundings. So, the main aim is to minimize the regret, which is the difference between the regret you gain and the optimal regret which you can get. And you have to maximize rewards, which is basic. So the common methods to solve this are Thompson sampling and upper confidence bound. These two methods are used to solve this decision making problem. So our paper mainly deals with this knowledge infused policy gradient upper confidence bound. So it was proposed by Roy and his team, which combines domain knowledge along with UCB, which is upper confidence bound, to take better decisions in dynamic situations. So the mechanism here is there's a psi function which assigns contextual values, and it uses gradient optimization plus something called as expert knowledge, where +1 and -1 indicate favoring an action for a game state, or -1 indicates that it's reducing the that action to be taken in that particular game state. So UCB, as we know, it balances this exploration and exploitation, and it trains agent better. When compared to the previous approaches, this approach handles large action space and dynamic states efficiently. So the StarCraft environment is is a complex textbook which we have used to train our agent. It basically has partial observability that the agent can't see everything what's happening. So it requires exploring the state. Then there's a large amount of action space. So you have to take complex decisions. And it is dynamic in nature. So we have to develop something called adaptive strategies. So these are the table of inferences. As you can see, StarCraft 2 is where we have taken the game from, and now knowledge infused prone, if you see, we have taken the algorithm from there. And the grandmaster level in StarCraft is the previous research where they have trained the agent and those results. This is basic literature review. Then coming to the research gap, like so many advancements in RL are happening every day to day, but there are many challenges when it comes to applying to dynamic environments such as StarCraft. So reinforcement learning struggles to take smart decisions when the game is hidden or unknown. And there's many actions in the StarCraft game, so it makes the agent hard to explore and learn effective strategies. Then the models are trained on one map only, and it requires again retraining from scratch for other maps. So our research addresses these gaps by reducing the action space through use of domain-specific statistics, and it improves adaptability with using lightweight transfer learning between the maps, and it integrates the contextual awareness directly into the action selection. As a result, the proposed knowledge infused policy gradient with UCB framework provides a scalable and efficient solution for decision making in uncertain environments. We'll see how to the methodology. And as you can see, initially we have to adapt the algorithm in knowledge infused policy gradient with UCB for the StarCraft environment. Then we have to integrate this RL and UCB methods for exploration and along with domain specific tactics. Then the proposed architecture generally consists of policy learner, tactic manager, and scoring mechanism. In the upcoming slides, I'm going to explain in depth. Then to adapt this algorithm to StarCraft environment, we have our objective is to explore and exploit in real-time scenario. So StarCraft, as we know, it's gonna reduce the action space based on the predefined tactics, and the tactics are usually selected using a modified contextual multi-armed bandit framework. Then the agent uses input as the minimap screen and non-spatial data, and it focuses on tactical or strategical decision making over instead of using direct actions. So this is the policy learner. As you can see, the policy is computed using a sigmoid function, and it takes care of the history of the agent, the actions it performed, or the rewards it has gained over the past, and it selects the agent with the maximum policy value, and it applies that using the tactic manager, which I'm going to explain next slide, and it gets a reward. And to get this exploration into the game, you have to generally use a confidence bound term, and how much the tactic probability has changed, encouraging it to explore when the uncertainty is high. Then we apply this policy gradient, which is how it scores and adjusts the values of tactic rewards and the confidence bound and selection probability of that particular tactic. Then we have we are using a regression tree to smoothen the gradient, which allows us to get a stable and incremental learning over time. Then the tactic manager. This is the main thing which manages and executes the switching of the tactics in dynamics real time during the gameplay. It initially has a list of tactics for a game state. Then it checks whether to switch a new tactic using a dynamic flag. If switching is required, it selects the best tactic using the select tactic function. Then it assigns the executor to perform the tactic selection. Then it monitors all tactic execution, whether it's completed or not. If it is completed, it sees to switch to a new flag or not. And it loops continuously until the game is active and it's evolving until a end of the game state is reached. So this algorithm continuously evaluates and switches the tactics based on the game progression, ensuring that the adaptive and strategic agent behavior is involved. Well, it comes to the tactic selection, how it chooses the most promising tactic from available action, and it uses scoring based on learning and the performance metrics. So it iterates over each tactic, checks if that action is executable for the tactic, and it calculates a score based on the game. So it selects the tactic with high score, and if there's no tactic available for that action, it returns none, so that it's basically to handle errors. So this algorithm uses learn scores to select the best tactic. It balances exploration, exploitation, and recent performance of the agent. So how the score is calculated for each game is like we have three terms: mean reward, exploration term, and recency factor. The mean reward is just the average of past performance of the tactic it performed, and this exploration term is the confidence bound term. There is a parameter C which controls if it is higher, it is giving the agent more chance to explore. If it is lower, it is to exploit. And the recency factor is exponentially moving average of recent rewards, and it makes the agent responsive to the recent performance when compared to the older actions. So the score is just the sum of these three terms. It generally balances the exploitation of well-performing tactics and exploration of underused ones and adaptation to recent outcomes. So these are the games. Actually, the game is very huge and complex. So what this Google's AI DeepMind people have done is they have segregated the game into mini games, where each mini game has its own features, and we have used 5 mini games out of 7. Those are collect mineral shards, where there are 2 marines to gather the scattered shards. In this mini game is used to test the movement and reflexes. Then there is defeat roaches, when there are 9 marines and 4 roaches, and each roach kill, they'll get a +10. And if marine is lost, there's a -1. And every new wave is spawned after each episode or game. This focuses on combat efficiency. Then similar to defeat roaches, there's another mini game called defeat zerlings and bearlings. This has different enemies, that's it, and +5 for each kill. This emphasizes the transfer learning and adaptation. Then there's a collect gas and minerals. This is to gather resources within a time limit, and it requires us efficient management and planning. Then there is build marine. That you have to start with a basic base and earn rewards for training marines, and it focuses on base building and long-term planning. So the results in our case were we have trained the agent for on means and max scores are this shown in this table. As you can see, we have compared with uh, state-of-the-art systems like DeepMind's Baseline and Human Player and Grandmaster. So our agent has performed very well in 4 games out of 5 games, which is collect mineral shards and collect minerals and gases, then defeat Zerlings and Bailings and Bill Marines. It has successfully performed there. The key factor here is the the tactic-based action selection and domain knowledge excelled in resource management and unit training, whereas their challenges were when it comes to defeat like combat games like defeat roaches and defeat Zerlings and Berlins. As you can see, its static rules were limited the adaptability of the agent and it failed real-time unit location. Then there is something called lacking of multi-unit coordination and adaptability. And in defeat Zerlings and Bailings, it overpriced units like Marines versus Bailings instead of fighting with Zerlings. So the insights of the discussion which we can bring up based on the results are rule-based strategies work well in structured tasks such as resource management, whereas when it comes to combat situation, the agent is weakly adaptable and it struggled a lot due to its limited flexibility and generalizability. The conclusion here is that combining manual tactics with RL or reinforcement learning boosted the agent performance across many games, and that this algorithm this technique also outperformed DeepMind's deep learning agent based training in resource oriented and structured tasks, whereas high level domain specific strategies improved task efficiency and management. Then, when it comes to combat situation, the fixed strategies underperformed in dynamic combat scenarios, underscoring the need of flexibility. Overall, you can see that the knowledge-infused policy gradient approach with UCB approach has validated the importance of strategic flexibility in complex decision making. So the future work where you can focus is like you can enhance or improve the cooperation coordination to close the gap between skilled human players, especially in dynamic partial observability settings. And further, there can be hybrid approaches introduced to develop deep reinforcement learning combined with manual tactics to boost this flexibility and performance. And you can apply transfer learning to reduce the training time and computation costs for scalable solutions. And if you're gonna take this knowledge infused policy gradient with UCB to real world domains, which require dynamic decision making such as autonomous systems or robotics or finance, healthcare. This is the take you can see in future. Then these are some of the references we have used for our paper. And thank you for your attention. We appreciate your time and interest in your work.
So thank you very much for your presentation. I'm very happy for your presentation style, and you have
Yeah, thank
performed
you.
a very good research work. My question is that how does IPG, that is Influence Policy Guardian, perform in partially observable environments?
It basically has performed well, but there is a lot of exploitation of the actions generally. So the agent has not used the exploration parameter over there. So we are using this UCB to include the exploration so that the agent can get to know strategies better than that. Instead of some suboptimal strategies, we can get to know more optimal strategies, right? That's why it has performed not so well, but up to a stage it has done good. But
Okay.
introducing the parameter is great.
No problem. Thank you very much.
Thank you, Petra.
Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Rajeshri H with the paper title Design and Development of Radar Module for the Analysis of Interference Mitigation Techniques in NS3. Ma'am, if you're ready, then you may start with your presentation.
Yeah. Thank you so much. So good evening all. Just a minute, I'll share my screen.
Sure, ma'am.
I guess my screen is visible to all of you.
Yes, ma'am, it is visible.
Yeah, thank you so much. So yeah, my work is all about design and development of radar module for the analysis of interference and its mitigation strategies in NS3. So now moving on, we have mainly worked with an FMCW radar. They predominantly operate in 22 to 29. However, our focus is on about the 77 and 81 gigahertz that is mainly used for autonomous vehicles. So now here we have the chirps that transmit and reflect off the targets through which we can calculate the target distance. So that could be either of a sawtooth, triangular, or striped. And also the range estimation relies on the frequency and the time delay of the return signal. Now, why particularly the FMCW radar? Because they are resistant to weather and material penetration. However, the presence of interference does lead to misdetection of the targets and also false detection probability. So here why we have gone with an NS3 simulation, because we wanted to do a scalable testing and the validation of radar protocols, because the real-time hardware validation is pretty difficult and as well costly. So mainly my literature survey I've classified into three main categories. The first is we have a conventional mitigation strategies like the standardization, master slave synchronization, spectrum sensing before transmission, or at least starting the chirp rates at different time interval will reduce interference to a certain extent. Now we also have another classification based on the algorithmic and protocol based. We have the Texas Instruments interference mitigation along with unslotted aloha frequency hopping, which is mainly we have tested our framework with. Then we have a carrier sensing model, works well for co-located and distributed network. Then also a RAD-SHART protocol developed by IORGO. This is mainly a time frequency MAC protocol to coordinate radar communication. Then also we have a Bluetooth-based FMCW radar protocol, mainly diffuses attack energy and improves the signal to interference ratio. Then finally we have the CSMA protocol, enhances the throughput and reduces narrowband interference. Then we also have bio-inspired and adaptive methods. First is we have the European BAT based frequency hopping techniques and adaptive hopping based on real-time interference assessment. So here what happens is mainly we have the emerging techniques. Mainly when going to the signal processing, we have the phase coded FMCW, DFT, STFT, morphological component analysis, then one-dimensional, two-dimensional fast frequency transform. Sometimes what can happen is a radar can also be clubbed with a communication system like 5G and work together. So for which we have a neighbor discovery protocol that has been developed by OSCAPTON. So what mainly is an open research problem is mainly the lack of multi-targeting studies within the simulation framework. So this has motivated us to develop and evaluate an FMCW radar in NS3 with realistic models as well protocols. So here my radar module design mainly consists of my radar node, channel as well the target, and also my radar module includes the physical as well the MAC layers in the net device. Now this is pretty similar to the Wi-Fi module present in an NS3. We have taken inspiration and we have developed our own radar module. So mainly the physical layer takes care of the transmission and reception of the signal, enabling the multi-input and multi-output radar. Radar MAC handles for the channel access coordination as well the contention mitigation. Now mainly in the targets we have a backscattering to reflect the signals. Then finally we have classified the events like transmit event, forward event and backscatter event to model the entire radar behavior. So now this is the architecture of our radar module in an NS3. So here we basically have a radar node which encompasses the net device, a radar MAC, and in the radar physical we have the transmitter receiver that is connected to a common channel with the transmitter and the receiver antennas and the radar target. And these are the hyperparameters values which was we have developed, we have generated our own signaling and tested the modules. Then moving on, we have the various transmission blocks. As I told you, we have the transmission, backscattering, and the forwarding blocks. So now all the event data will be encapsulated in one block called the signal, which will be the custom object. So this will basically represent the radar signal with its metadata as well the waveform. So now this will ensure the seamless data flow between the radar components during the simulation. And also there is a lock to add on the values if not configured properly. So now this will basically enable an end-to-end radar module in an event-driven NS3 environment. Then moving on to a target, mainly in the transmit event, we will have all the hyperparameters fed like the frequency, chirp duration, chirp slope. That is very essential to generate the radar signaling waveform. So this will form the basis of a radar propagation as well as the interaction modeling. Then moving on, we have another module called backscatter. So here it will be performing three main operations. The first is a distance measurement between the target as well the radar. Then the delay calculation. Finally, the backscatter signal generation that will be used to calculate the range of the object. So now this is very, very crucial because this help in the frequency analysis and the target localization post the fast Fourier transform. Then also, finally, we have this will be in the physical layer. Then we also have a layer introduced called the MAC layer. Now, this will be the main in a radar system, mainly responsible for scheduling and organizing the communication. So main critical roles will be transmission scheduling as well as interference reduction. mainly ensures accurate target detection, relies on the MAC protocols used. Then we have some traditional MAC protocol strategies. First is setting the signaling strength to 0 during an interference. So now what happens is when you basically zero the signal during the interference, this will completely degrade the performance because I may lose the target. I may not be able to detect the target, especially when the target as well interference coexist. So here we go with a standard protocol to test our NS3 module. Then the other core functionalities will be flag-based handling, thread-safe operations, spectrum efficiency, high detection reliability, as well as performance lagging. Then this is the flowchart of the unslotted Aloha with a frequency hopping module we have used. First is we basically initialize the parameters. So here, since it operates, we have taken a few frequencies and try to operate a radar in all these frequencies. So sometimes what happens is whenever there is a possibility of interference, the frequency hopping will be called. So that will detect the collision. Then it will try to hop into a new frequency, and once again the entire process will be repeated. Now, say for example, when interference happens specifically on a particular frequency over and over again, that will be considered as a bad frequency and eliminated. Then moving on, mainly this we have combined the unslotted aloha and the frequency hopping. Now this is mainly done is to enhance the spectrum usage because we have multiple radar coexisting. It's very important the spectrum is shared among the radars effectively, and also this will reduce collision in case of a dense environment. So here what happens is all the frequencies will be randomly shuffled and fairly assigned to the nodes, and frequency pool will be cycled when exhausted, ensuring all the nodes are transmitted. So bad frequency will be removed and updated dynamically. So this basically we have represented it as a probability of transmission. So transmission occurs basically randomly only when the R is less than the transmission. So here what happens is simultaneously we avoid the transmission in order to mitigate the interference. Then also in case of any detection of a collision, the frequency hopping will be triggered and the radar will hop into the next available frequency in the pool. So mainly we have a cyclic index that is used for fair and distribution of frequency among the radars. So this prevents repeated collision on the same frequency. Now if all the frequencies are used, this finally logs the error and pauses the transmission. So this will allow time for the pool replenishment. So this ensures robustness even under high radar density conditions. Then moving on, we also have another very important algorithm, a standard algorithm, which we tested our module with, which is nothing but the TIs or the Texas Instruments interference mitigation algorithm. So here what happens is when the interference of the aggressor chip overlaps with the victim radar. So that what happens is we basically have an overlap of both. So this will cause glitches in the ADC data and degrades FFT performance. So this will invariably affect the target detection. So here what happens is now basically this glitch depends on what is the distance between the aggressor as well as the victim, the antenna gains. So now what happens is two main statistics are calculated, absolute sum as well absolute difference. So these metrics will help us highlight the interference regions. So then what happens is we basically have a threshold that will be derived from the absolute sum and difference. So sample crossing the threshold values will be flagged as interference indicator bits. So now the other strategies we have included is zeroing, mainly replace affected sample with 0. However, this is not much of an efficient task, but for preliminary we make it 0. Then finally, we are also applying a window function to reduce the side lobe. Finally, we also apply the linear interpolation technique that will clean the samples before and after interference. Now, this mainly we have applied it for strong reflectors at lower frequency. So now these techniques preserve target information in a noisy scenario. This also adapts to interference types as well strength. Then finally, the algorithm flow, we mainly detect the interference, check if any interference exists. If detected, we call the in ADC data. So there we'll be computing the threshold values. Then finally, we'll be applying the linear interpolation if it is surrounded by valid data, zeroing if there is no clean context. The final ADC data will be further cleaned for further FFT as well as detection. And this technique has proved to be efficient in terms of interference mitigation. So now this diagram represents a radar topology in our NS3 framework. So the first is we have a 3 radar as well as 3 target, and these are the distances with which the radars are placed. And then based on these interference that are happening, we have applied the
Really
protocol.
sorry to disturb you, but I'd like to remind you of the time limit.
Yes, it is done, ma'am. We are going to the last slide. It is done. So now moving on to the comparative graph, mainly I've taken two graphs. One is the transmission time as well as target detection probability. So this represents the transmission probability for the three radars, and the next graph will be the target detection probability. So from the graphs, you basically analyze this. Radar 1 and 2, they are trying to do a multiple attempt. Now radar 1 is successful because it has achieved 100%. Now this indicates no interference. However, the other two radars, they struggle due to interference. Now applying these techniques, on the 10th attempt, the radar 3 has achieved 10% success, whereas radar 2 has achieved a probability of 9% in its 11th attempt, reflecting gradual resolution of the channel contention. Similarly, in case of a target detection, so in terms of a 5 radar and 5 target, we have increased the number of radars. We have tried to test the module. There again, what has happened is in terms of radar 4 and 5, the possibilities are 11% and 12.5% in the 9th and 10th attempt. So this the protocol is very progressive in managing the access and enhancing mitigating interference. So now the main conclusion is the radars is proliferated in various fields. Now this has led to interference. So now we are trying to apply different techniques. So now we need an emulation environment to test these protocol. On this context, we have developed a NS3 protocol and tested the standard modules. So now these researchers can even amalgamate their protocols in our module and they can validate it. So two main convention mitigation algorithms have been introduced. So one is the TIs as well the frequency hopping and the unslotted alloga. In future, we are trying to validate with a real-time environment. Thank you.
Yes, very good presentation from Rajeshri.
Thank you, sir.
My question is that what type of protocol are used for a development of this radar module?
Sir, in the sense, what protocols in the sense? Interference mitigation protocols?
Yeah.
Sir, mainly our current focus is on three protocols. For this
Yeah.
NS3 module, we have used unslotted aloha and frequency hopping. Then another standard module we have tested with the Texas Instruments interference mitigation algorithm. So now the next we are actually testing it with CSMA also. So that work is
Yeah.
also really going on. So here what we are trying to do in our next module is we are bringing in ML concept. So now we are developing an ML based CSMA to test and reduce the contention of the radar interference, because the problem with the normal CSMA module is, see, when I have multiple radars in a situation, what my CSMA will do is it will completely stop the transmission of other radars. Only one radar will be communicating. Now this is okay when I have a single radar and a single target. Now suppose in a real-time environment I will have multiple radars. So now only one radar is communicating, when the other radars are stopping, so the target misdetection and the radars don't communicate, so they don't detect the target at all. So the target misdetection probability of those radars will be very, very high. So the other radars won't have a chance at all. So now that is the main problem in a traditional CSMA module. Now, when you try to introduce a machine learning and an artificial intelligence concept with the CSMA, what we can do is the spectrum can be efficiently managed. Even now in this module, what happens is, as you can see, sir, in the multi environment, the radar 1 is communicating with 100%. Now, whereas the rest of the radars are not, they are only with a 12% and 11% or 9% of 12.5% of target detection and transmission probability. So now when we try to scale with a machine learning module, so these problems can be resolved. So the channel can be efficiently used, and also I can ensure the other radars also communicate. My target misdetection probability for the other radars can be substantially reduced. As well, my SIR can be increased for those radars also. So that is what is our next objective, and we are working on that, sir.
Okay. Thank you very much.
Thank you so much. Thank you.
Thank you.
Thank you, ma'am. Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter, just a second, Tanya, with the paper title Licensing and Technology Commercialization, a Literature Review. Ma'am, if you're ready, then you may go ahead.
Yeah. Just a minute to share. I think you can see my presentation.
Yes, ma'am, it is visible.
Yeah. So, good afternoon. My name is Tanya Azevedo, and I will present the article Licensing and Technology Commercialization, a Literature Review, co-authored with Nuno Rodrigues. Nowadays, we live in an economy based on knowledge, where values lies in the capacity to innovate, where universities and companies are constantly generating scientific discoveries. However, turning these discoveries into marketable products or service is not a simple task. In this context, licensing and technology commercialization have become fundamental for bridging the gap between the lab and the market. Managing intellectual property, negotiating effective licensing agreements, and building strategic partnerships are now key for transforming innovation into real economic and social impact. To achieve this, the main objective was to identify the empirical and conceptual studies on the licensing and technology commercialization scope, guided by the research question, what is the present knowledge regarding licensing and technology commercialization? To develop the current study was applied the framework suggested by Daniel and Tranfield. This framework includes 5 steps. First, formulate the research question, identify the studies to incorporate, select the chosen studies, analyze the gathered information, and detail the outcomes achieved from the prior steps. Analyzing literature, it was possible to identify patents and trademarks as essential tools for protecting innovation. However, it's not only about protection. Well-managed intellectual property enables organizations to generate profits through licensing, transforming intangible assets into real economic value. Another key aspect that emerged from the review is the importance of royalty structures and the contract experience of licensing managers. Poorly designed contracts can compromise the commercial potential of technology. The review also highlights 2 major challenges. First, the need to balance legal control over innovations with openness required to attract new partners. And second, the presence of bias in licensing decisions, often influenced by subjective perceptions of inventors. This last point raises serious concerns about equity and effectiveness in the technology transfer process. When analyzing commercialization strategies, the literature shows that the strength of intellectual property protection directly influence the chosen path. When patents are robust, universities are more likely to opt for external licensing. On the other hand, when protection is weak, it is common to see the creation of spin-offs, where the inventors themselves take on the commercialization process. Another essential point is the business model. For a technology to succeed in the market, the business model must be scalable and aligned with the dynamics of the market. And the experience of licensing officers also proves to be a key factor. More experienced professionals are able to negotiate better agreements, reduce risks, and anticipate legal or commercial issues. And finally, royalties based on performance align the interests of universities and licensing companies, sharing risks and encouraging mutual commitment. Universities play an absolutely central role in technology transfer, and the literature shows that a university's scientific reputation has a direct impact on licensing success. More prestigious institutions attract greater interest from companies and investors, which facilitates the commercialization process. A decisive factor in engaging inventors is the existence of clear incentives which increase research involvement. Technology transfer offices serve as crucial intermediaries between academia and the business sector. They are responsible for translating scientific potential into market opportunities. And finally, several studies highlight the importance of more informal and flexible practices in knowledge transfer processes. These less bureaucratic and more collaborative approaches are shown positive results and in fostering innovation networks and accelerating the commercialization of new technology. Despite recent progress, technology commercialization still faces significant challenges, especially in emerging fields such as nanotechnology. In these areas, uncertainty regarding market potential or technology maturity tends to delay licensing processes. A critical issue highlighted in the literature is bias in licensing decisions, often influenced by the inventor's profile. Factors such as gender, collaboration style, or previous experience may affect how licensing managers perceive inventors. These raise serious concerns about fairness and effectiveness in technology transfer process. And lastly, the costs associated with identifying commercial partners and searching for market opportunities remain recurring obstacles. This process is still time-consuming and inefficient, especially for technologies without a clear application path or for institutions with limited resources. The literature clearly highlights the value of partnerships between universities and companies as an effective way to reduce the risks associated with technology commercialization. These collaborations combine scientific expertise with business execution capabilities, increasing the chances of market success. A key element in these partnerships is the use of performance-based agreements, which help align the interests of all parties and fostering a stronger commitment to the success of the innovation. Another crucial point is the role of complementary assets. Many universities and startups lack these resources internally, making partnerships essential. Finally, it's important to emphasize that strategic alliances are especially critical for SMEs, which often face financial and operational constraints. For these firms, collaboration with academic institutions can be a powerful way to access innovation and compete in dynamic markets. To conclude, this review consistently shows that IP management and licensing are fundamental for the valorization of innovation. Without a strategic approach in these areas, many technologies fail to reach the market. It also became clear that universities need to adopt more flexible and inclusive technology transfer practices. Regarding future research, we identified 4 priority areas, such as bias mitigation in licensing, accessible IP strategies for startups, digital platforms, and open innovation networks, and legal frameworks. If you have any questions or would like to discuss future collaborations, here are our contact details. Thank you.
Yes, thank you. Thank you very much, Ms. Tanya. My simple question is that what are the core elements for the licensing and technology commercialization?
I would say partnerships with people that are used to deal with this kind of problems, because it could be very bureaucratic, and this partnership can reduce the risks of that and consequently the costs.
Okay. Thank you. Thank you very much.
Thank you.
Thank you, ma'am. I'd like to invite the next paper presenter. We have Hong Gian Nguyen with the paper title Predicting Asian University Rankings Using Deep Learning, the Asia 2025 Analysis. So if you're ready, then you may go ahead. Sir Hong Gian. Seems we do not have him in the meeting with us.
Maybe he is not available in the meeting.
Yes, sir. Just a second.
Yeah.
Okay, so This brings us to the end of our session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I'd also like to thank the session chair. Just a second. Professor Shyam Akashe for chairing the session. A token to the chair on behalf of Team ICTIS 2025 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you. Thank you very much. Thank you.
Thank you. Just before we end the session, I'd like to request everyone to turn on the cameras for a quick snapshot of the virtual conference.
I request to everyone, please open your cameras.
Thank you, everyone. Stay safe and take care. Thank you, sir.
Yes, thank you. Have a good day.
Yes, thank you.